So in this video, I'm going to discuss the longest non-decreasing subarray from two arrays which occurred in today's LEETCODE challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem statement is very simple. You're given two arrays and you can merge them by by making a third array. And the specialty about this third array is that you can, for every position, you can choose either the element from the first array or the second array. So you have to find the longest non-decreasing subarray which can be formed from this two arrays. Okay, the length of that thing. Okay, so for this, the approach would be like, if we take from 1 and 2, if we take 1, and from 2 and 3 if we take 2, and then from 1 and 1 we have to take 1. So the longest non-decreasing subarray is this 1 2, so the length of that is 2. For this, the approach would be take from 1 and 2 take 1, from 2 and 3 take 2, from 2 and 3 take 3, and from 1 and 4 take 4. Okay, so 1 2 3 4, so the longest is 4, of length 4. For this, from 1 and 2 take 1, and from 1 and 2 take 2, so the longest is 2. Now very much evident it is that you can't use greedy, because see, from here, in the first position we chose the smallest element, and the second position we chose the largest element. And there may be like exceptions, like there may be more exceptions, and the answer may get more and more complex. Okay, so remember one thing, that for this, if we would have chosen 1 also, then also it would have been given 2. But there may be cases when we have to choose the, like, we don't know what to choose. Okay, so for this concept, greedy is not gonna work. So what is gonna work? It is dynamic programming. Okay, so what do we have to do in this? So let's say dp, so we have to make a dp for array 1 of size n, and a dp for array 2 of size n. Okay, and initially dp 1 of 0 is 1 and dp 2 of 0 is 1. That is, if we take just the first element from any one of the arrays, so we are going to get a subsequent the length of the longest subarray as 1, right? So we can take initially at 1. Okay, and we have to check for every element, if this element is greater than equal to this element, then the dp at this position will be this plus 1. And if this element is greater than equal to this element, then the dp at this position will be this plus 1, because we can add this element. Okay, in case like this thing is completely dependent on its previous element. Okay, previous element, since it is a subarray, so every element is compared to its previous element, so it is completely dependent on this previous element. So I can give you a pseudo code. So that is, you can run a loop from 1 to n minus 1, and if nums 1 of I is greater than equal to nums 1 of I minus 1, then you can make dp1 of I as maximum of dp1 of I, comma, because there may be some cases when, like, after performing one approach, you may think that no, like, we don't need to consider the other ones, because this is going to give me a better approach. That's, this portion is kind of greedy, this maximum thing, this is the greedy part. Okay, which is very much nominal, like it's not much in use. And dp1 of I minus 1 plus 1. Okay, and similarly you can do this, this thing you can do for nums 2 of I and nums 1 of I minus 1, or nums 2 of I and nums 2 of I minus 1, and nums 1 of I and nums 2 of I minus 1. That is, there are 4 conditions, right? That is nums 1 nums 1, nums 1 nums 2, nums 2 nums 1, nums 2 nums 2. And for every one you have to like change this thing. That is, when you're using nums 2, you have to, in this case, instead of writing dp1, you have to use dp2, right? So let's like perform this thing for this one, which is 2 3 1 and 1 2 1, right? So 2 3 1 and 1 2 1. So the dp1 and dp2 would look like initially 1 0 0 and 1 0 0, right? So for this first thing we don't have to check because that is like the basic approach. So for this 3 you have to check if 3 is greater than equal to 2 or not. Yep, this is greater than equal to 2. So you have to, over here we have to write maximum of 0 comma 1 plus 1, right? Maximum of 0 comma this 2, you can add 3 to that one, that is 1 plus 1, that is this plus 1, so that is 2, right? And over here again you have to check if 3 is greater than equal to 1 or not, right? If 3 is greater than equal to 1, if 3 is greater than equal to 1, yes, so you can write maximum of 2 comma 1 plus 1, that is it remains 2, right? So we don't have to change it. For this position you have to check again, see the same thing, this is also greater than equal to this, and this is also greater than equal to this. So what we can do is, for this first condition, maximum of 0 comma 1 plus 1, that is 2, and maximum of 2 comma 1 plus 1, that is also 2, right? For this position 1, you have to check if it is like 1, if 3 is greater than equal to, sorry, is 1 is greater than equal to 3, nope. 1 is greater than equal to 2, nope. 1 is greater than equal to 3, nope. 1 is greater than equal to 2, nope. So it remains 0, and the answer is going to be the maximum of all the elements from dp1 and dp2. So from dp1 the maximum is 2, and from dp2 the maximum is 2. So maximum of 2 comma 2 is 2, so we return 2. For this also we can perform it. Okay, so let's do it simultaneously. 0 0 0 and 1 0 0 0. Okay, for now, for the time being, I'm writing this 4 over here. So for 3 you have to check, yes, both of them satisfies. So 0 comma 1 plus 1, that is 2, and 2 comma 1 plus 1, that is 2. For this also both of them satisfies. So same thing, 0 comma 1 plus 1 and 2 comma 1 plus 1. For this 2, this satisfies, but this does not. Okay, so this satisfies, that means 0 comma 2 plus 1, right? That is 3. And for this 3, both of them satisfies again. So 0 comma 2 plus 1, that is 3, and 3 comma 2 plus 1, that is 3 also. Okay, and for this 1, neither of them satisfies, but for this 4, both of them satisfies, right? So this is going to become 0 comma 3 plus 1, maximum of 0 comma 3 plus 1, that is 4, and this becomes, sorry, not this one, this remains 0 because this was 1, right? So this becomes maximum of 0 plus 3, 0 comma 1 plus 3, that is 4, and this becomes again 4 comma 3 plus 1, that is 4 comma 4. Maximum of 4 comma 4 is 4. So what is the largest from the dp1? It is 3. And what is the largest from dp2? It is 4. So what is the maximum of dp of this 3 and 4? The answer is 4, right? For this 2 2 1 1, the dp looks like this, 1 1 1 0. So for this element, is 2 is lesser than equal to 2? Yeah, 2 is lesser than equal, sorry, 2 is greater than equal to 2, and 2 is greater than equal to 1, right? So this becomes 0 comma 1 plus 1, 2, 2 comma 1 plus 1, 2. And this for 1, this does not satisfy, but this satisfies. So that means it becomes 0 comma 1 plus 1, that is 2. Okay, the maximum of 0 comma 1 plus 1. So from this the maximum is 2, and from this the maximum is 2. The maximum of these two is this. So this is how this problem has to be solved using dynamic programming. That's it from my side. Thank you.